Now, the picture shows an ancient city wall of China. An architect studying the structure of the wall needs to find its measure. We can model the wall with a trapezium ABCD. The middle gate is made up of a semicircle and a rectangle. All lengths are measured in meters. Find the perimeter and area of the figure. Okay, so actually they just want to find this length here. Okay, so this is a semicircle, right, at this point. Okay, so they put there, this length here is 1. Okay, hope you can see. Okay, so here is 1, here should be 1. Right, so let's go about finding the perimeter. Okay, so perimeter of figure. Okay, so let's start with what we have, which is 11, 4.03, 4.03. 11 plus 4.03 plus 4.03 plus 4.5, 4.5 plus, okay, then we plus the two ones here, 1 here, 1 here. Okay, then we plus, now we need to add this semicircle, right? So as we know, if this is the semicircle and this whole space is 3, that means our radius is 1.5 cm. Okay, so what is our formula for semicircle? Pi r. Okay, so pi times 1.5. Right, because your circumference of circle is 2 pi r. Okay, so semicircle pi r. Right. Okay, without the line. Semicircle pi r. Okay, so we have to use our calculator because now it's not in terms of pi. We have to correct to 3 significant figure. So let us find our circle first, which is pi. Oops. Pi times 1.5. Okay. Plus 2 plus 9 plus, right, because here is 9. 2 plus 9 plus 8.06, 8.06, oops, 8.06 plus 11. Okay, and we should get 34.772. Okay, round out to 3SF, 34.8 cm. 3 significant figure. Okay, then they want you to find the area. Now, if you want to find the area, you must be a bit smart about it instead of finding piece by piece. Okay, so what we can do is, we can actually find this whole trapezium first. Right, this is a trapezium, right? So we find this whole trapezium first. Then we minus the area of the semicircle. Then we minus away the area of the rectangle. And we can get the area of our this shape. Okay, so we take the whole area of this whole trapezium, then we minus away this rectangle, and then we minus away this semicircle. Okay, so that will be the easier way to solve this question. Okay, so I'm going to start with area of figure. Okay, half. The two lengths will be 11 plus 9 plus 3. Okay, so 4.5 plus 4.5 is 9. 9 plus 3. So 9 plus 3 will give me 12. So 12 plus 11 times my perpendicular height. So did they give us a perpendicular height? Yes, they did. The perpendicular height is here, 4. Right, the perpendicular height is here, 4. Right, not the slanted length here, 4.3. This is slanted. See, what we want is the perpendicular height, 4. Okay, so we times 4. Right, then we minus away this rectangle. This rectangle is 3 times 1. Okay, 3 times 1. Then we minus away this area of semicircle. So if you remember your area of semicircle, your circle is pi r square. Your semicircle area will be half pi r square. And r square here is 1.5. Half of it, right? So you minus half pi times 1.5 square. Right, okay. So from here, divide by 2. This is 23 times 6. Okay, 23 times 6, 46. No, 23 times 2, sorry. 23 times 2 is 46. Okay, then we minus away 3. Then we minus away this one, which is 1.5 square times pi times 0.5, which is 3.534291 something. Okay, so knowing this, alright, I'm gonna clear. 46 minus 3 is 43 minus answer just now 4.72. Okay, 3 minus, okay, I'm going to retype it, 0.5 times pi times 1.5 square. Okay, I will get 39.4657. Round up to 39.5. Okay, meter, right? Meter square. 3SF, same as the other one. Okay, so hope this video helps. Right, then try yourself. Okay, let's go on to the work example 14. Now the shape ABCD represents a playpen. Alright, all lengths are measured in meters. If a playpen has an area of 43, find the value of x. Okay, x is this value here. Alright, and this value here, prevalent on both sides. Okay, but you notice that the two triangles are different. Right, here is x times 2, here is x times 3. Right, so how do we go about finding this this value of x? Okay, first of all, you know that this is a rectangle, right? What am I looking at? I'm looking at this one. Okay, this is a whole rectangle. Right, what is the base times height? This is 6, 8. Okay, so I'm going to take area of rectangle, minus away this triangle, area of this triangle, and minus away this area of this triangle, because we know that this area playpen is 43 meters square. Okay, so area A, B, C, D, E, F equals to 43. How to get 43? I'm going to take 4 times 6. No, sorry, 6 times 8. Alright, for the area of the entire rectangle, 6 times 8. Okay, then I'm just going to minus off this rectangle first. So half times x times 2. Half times x times 2. Then I'm going to minus off half times x times 3. Okay, so when I expand everything, this is 48 minus half and 2 multiply, I get x minus x. This one, half and 3 divide, I get 1.5. So I get minus 1.5x. Okay, so combine the two x's, 2.5x 43. Alright, then now what I'm going to do, I'm going to transfer this over. Okay, becomes plus 2.5x. Okay, so I get 48 equals to 43 plus 2.5x. Okay, then I transfer this one over, becomes minus 43. So I get 48 minus 43 equals to 2.5x. I get 5 equals to 2.5x. Right, my x is 5 divided by 2.5. I get 2. Okay, you can? Hope it's simple. So this is what I mean by find the value of x. You need to form an equation. and then solve for x. Okay, hope you are able to understand this one. Okay, let's go on to the last question for this topic. Okay, two quadrilaterals ABCD, EFG overlap to form a figure as shown. ABCD is a rectangle and one is a parallelogram where EH is parallel to GF. Alright, so they are all parallel. They're all parallel, alright. Okay, so you have all these lengths and you have 42, right? From here to here, that means the height of the parallelogram, perpendicular height is 42. So they ask you to find area of rectangle ABCD. Okay, rectangle ABCD. Okay, so your total length, okay, we know that this is 13, this is 12, this is 15, right? So the length of the rectangle is 13 plus 12 plus 15, multiplied by 20. So 20 times 13 plus 12, sorry. 13 plus 12 plus 15. 20 times, okay, so add together 5, 40. 800 cm square. Okay, this is 15. Okay, now they want to find the area of the parallelogram EFGH. Now if this is 12, that means here is 12. Here is 12, here is 12. So we have the perpendicular height, we have the base length. So it's just 12 times 42. So area of EFGH, 12 times 42. Okay, so 12 times 42 will give me 504 cm square. Okay, so next one, they'll ask you to find the area of the parallelogram PQRS. Okay, and we know that if we look at PQRS, right, this parallelogram, the perpendicular height will be the base of the rectangle, right? So we know it's 12 times 20. Okay, so very easy. Area of PQRS, 12 times 20 cm square. Okay, the area of the figure. Area of the figure. Okay, so from here, what am I going to do? Okay, now if I find the area of parallelogram plus this rectangle, it is overlap here. So I need to minus off this area. Okay, so I'm going to find area of this rectangle plus this area of parallelogram. Then I'm going to minus away. Okay, I'm going to find this rectangle area plus this parallelogram. Okay, then I'm going to minus away this parallelogram because there's an overlap. Right, I just minus off one of these because there is an overlap. Right, so what am I going to do? And the question actually is leading you to answer because you found already all the different area. You even found the area of the small overlap, the parallelogram that overlaps. So you just need to add this plus this minus this. Right, so area of figure 800 plus 504 minus 240. So you get 04, 8 plus 1304 minus 240. Okay, you get 4, 6, 12, 1064. Okay, cm square. Alright. Okay, so it's pretty easy. So please go and try and finish up the try questions. We will go through them when I see you again on Monday.